In the first week of our energetic Earth, one of the things that we wanted to understand was this idea of energy input to the Earth and how the Earth doesn't distribute that energy uniformly. We have a very strong geometric component. This next week, one of the most important things to understand is that the Earth actually distributes this energy internally in a bunch of very important and very specific and very fascinating ways. And we're going to try to learn about that. And there's two key concepts we want to hit at the beginning of this week in this introduction. The first concept, which is a very straightforward one, is the one of a partition. A partition is where we take something that's whole and break it up into pieces that constitute that whole or that make up that whole. And I've brought an object lesson along just to make that a little bit more clear. I have 8 golden coins here, and these 8 golden coins can illustrate the idea very easily of a partition. We can break them up into pieces, so we have a group of 3 and another group of 3 and a group of 2. Or we perhaps have a group of 5 and a group of 2 and a group of 1. Those are different partitions. And one of the most important things that happens to a photon that's received by the Earth is it's partitioned into different possibilities. A photon can occasionally be reflected from a surface. That's one of the components. The other thing a photon can do is to pass or travel right through a surface as well. And that's the idea of a transmitted photon, or a photon can be absorbed. So for instance, photons on the surface of a lake can be reflected from the surface of the lake, they can be absorbed by the water in the lake, or they can be transmitted to lower levels within the lake, or even to the bottom of the lake. And so that key idea is that one of partition, of breaking things into pieces, and the pieces constitute the whole. One of the most important human questions is, how do you partition your day between work and sleep and play and eating and other kinds of activities? But the thing that's fascinating about the Earth, though, is it doesn't simply partition photons. By that absorption, there's often a process of readmission. The photons are sent out again into space, but not always. They can be recycled. And we can illustrate that idea very easily with these coins as well. Now I want you to imagine that I've got 8 coins, and you can ask the interesting question, how many of those could you spend? And the obvious answer would be that you could spend 8 of them if they were, of course, actual coins with actual value. But the answer is a little bit more interesting than that. It partly depends on whether you were to have an interest or a value in the store to which you purchase the coins. So I want you to imagine, for instance, that you're an owner of a store. And if you went into the store, you might say, I'm going to buy something with these 8 golden coins. But if you're an owner, that's not the end of the transaction. You might earn a profit, and you might get a certain fraction of them back. Let's assume 4. And now, even though I've spent 8 coins, I've still got 4 more that I can spend, so I can buy something new with them. But having just spent 4 coins and earned profit, I can get 2 of them back. And now I've spent 12 coins, but I still have 2, even from the original 8. From these 2, of course, I could spend 2 more, and I might get 1 back. This is really what is involved in the greenhouse effect that we're going to learn about this week. That the photons that are sent out from the Earth are absorbed, often by the atmosphere, often by clouds, and some of those can be recycled. They can be used again. And that secondary effect, that not only do we partition, but we recycle, gives us some basic insights into our energetic Earth.